Okay, here we go. Use the graph of y equals f of x to estimate the answers to the following questions. So, this was on your review sheet. -1, -2, -3, and there was a dot here, a dot here, a dot here, a dot here, and a dot down here, and it looks something like this, correct? Okay, so you have to find the local extreme values. This is f of x. That should go pretty smoothly on the test. I'm going to put the a down here. There's a maximum value at 0, 3. Be able to see that there's a maximum value. There is a minimum value at -2, -3. So we're done with A. B. What values of x is the derivative greater than 0? If you think of your sign chart, if the derivative is greater than 0, there's a plus sign on your first derivative. It's where the graph is increasing. So you need to figure out where the graph is increasing. It's increasing from here to here. So it's increasing from a -2 to 0. C. It must be less than 0 or decreasing on the other intervals. So a -infinity to a -2 union with 0 to infinity. Make sure that all of the intervals, that there's not a break in your graph, and there is no break in your graph. D, where is the double derivative? Positive. If you think of a sign chart, the double derivative is positive when it's concave up. So where is your graph concave up? It's concave up all the way to a -1. So from a -infinity to a -1. And E, where is it concave down? It's from a -1 to infinity. And I'm adding one more thing, F. So where is there a point of inflection? It's when you go from concave up to concave down, and I'll put it in red, it's right at a -1. So, you can go over this again if I went too fast, but the first problem on the test tomorrow should go pretty smoothly. Okay, the next page, I can delete that, sorry, I don't know why I added it. The next page, now instead of looking at a graph, you're supposed to make sign charts for the test. So, I need to make a sign chart for the first derivative, and I need to make a sign chart for the second derivative. This is the f of x, this is f of x, this is the interval. Okay, the first thing I have to do is find y prime, -4x to the third minus 2x plus 1. And what I'm going to do is use my Poly simulator and plug that in to find out that my only x value that they give me on my Poly simulator is 0.385. So I just need I need to go from a -infinity to 0.385, and I need to go 0.385 to infinity. That's all I need because I use my Poly simulator. And then what you're going to do is plug numbers in, and if you plug 0 into the derivative, it's going to be positive. If you plug 1 into the derivative, it's going to be negative. The first derivative tells you that it's increasing and decreasing. Okay, now I have to find my double derivative. My double derivative is a -12x to the second minus 2. I'm going to use my Poly simulator to come up with my answers. And my Poly simulator is going to say no real answers. So there are I can't make a double sign chart because there are no real answers. So I am done. So when I go up here and I say, where is it increasing? I can say for A, it's increasing. I can say it's increasing from a -infinity to 0.385. B, I can say it's decreasing from 0.385 to infinity. C, Where's the concave up and concave down? I'm going to talk about that in a minute. And E, I went from positive to negative, so there's a maximum. Whoops, right here. There's a maximum at 0.385. Plug that back into the original, and you're going to get 1.215 for the y value. Okay, now comes the C and the D. I got to talk about this. So just think about this. If your original problem is a negative even power, you should know what your graph kind of looks like. If it's a negative even power, it's going to be facing down, and it's going to look like that. So if you think about it, it's always concave down. It's never concave up. So for C, it's never concave. There is none. But for concave down, it's from a negative infinity to a positive infinity. F, you don't have a point of inflection. You don't have a point of inflection because you don't ever go from concave up to concave down. So that one is done. Okay, the next one. Again, I need to find y prime and y double prime. So I'm just going to do that first. Negative 6x squared plus 12x. And this one's a negative 12x plus 12. I'm going to make my charts because I think I need both of them. I guess we'll find out in a minute. This is the derivative. This is the behavior of f of x. This is the interval. This is the interval. This is f prime of x. This is, oops, double prime, I mean f of x. Okay, I'm going to use my Poly simulator to come up with my answers to both of these. I know I could set this equal to 0 and solve. I probably don't need my Poly simulator here. If I set this one equal to 0, and subtract 12, I know that x equals 1. I don't have to use my Poly simulator. If I set this one equal to 0, and I take the GCF out, which is 6x, I know I have two answers. My answers are 0 and 2. But if you want to use your Poly simulator, you can use your Poly simulator for the test. So, my first one, I'm going to go from a negative infinity to 0. I'm going to go 0 to 2. And I'm going to go 2 to infinity. This one, I'm only going to go from a negative infinity to 1 and 1 to infinity. Okay, now what I'm going to do is plug numbers in. Again, when you plug numbers in, you got to plug numbers into the derivative and into the double derivative to find out if it's positive and negative. I'm just going to hurry this up. It's going to go negative, positive, negative. What does that mean? The first derivative tests increasing, decreasing, max, and mins. It's decreasing, it's increasing, it's decreasing. Double derivative, I'm going to plug like 0 into the double derivative, and it ends up being positive, and this ends up being negative. What does that test? Concavity. If it's positive, it's concave up. If it's negative, it's concave down. So, if I want to fill in the A, B, C, D, here's the A, here's the B, here's the C, here's the D, here's the E, and I think it goes all the way to F, correct? Where is it increasing? So you look at your chart. It's increasing from 0 to 2. Where is it decreasing? Decreasing from a negative infinity to 0 and 2 to infinity. C tests concave up. Well, it's concave up from a negative infinity to 1, concave down from 1 to infinity. Okay, now comes the next part, the E. The E test for right here, there's a min and there's a max. Everybody see that? There's a min and there's a max. This is the min and this spot's the max. So I'm going to write that down. There's a min at 0, comma something. And there's a max at 2 comma something. And how do you figure out the point? Some of you forget to find the y value. You plug 0 back into the original, and you get negative 3. And you plug 2 back into the original, and you get 5. Okay, and the last one, there's a point of inflection when you go from positive to negative or negative to positive at 1, and you plug 1 back into the original, and you get 1. Make sure you find the y value. Okay, the next problem. Use a graph to estimate the following intervals. So I'm going to go off of here, and no, I'm just going to show you on. So you're going to graph it. So you're going to go under your graphing calculator, and this is key right here, it's estimate. Everybody could have different answers depending on what you do under your graphing calculator. So under Y1, you're going to put this under Y1 under your graphing calculator. You're going to change your window to what it says, from a negative 5 to 5 by negative 0.4 by 0.4. And then when you graph it, this is what the graph's going to look like. It looks something like this, and I know this isn't going to be perfect, but it looks something like that on your graphing calculator. Okay, so once you graph it and you changed your window, you need to go to second calculate and find the max. So remember how you do the left and the right. And it's going to tell you that the max is, mine told me that my max was exactly at 2, 0.25. And then I did second calculate, and I found the min, and my calculator told me 2 and negative 0.25. If you change your window, your min and max might change. So I'm just going to go off of what you tell me your max and min is. Okay, so far so good. Okay, where is it increasing? Well, you should be able to tell. Well, it's increasing. It's increasing. Do you notice that it's decreasing to here? And then it's increasing. And then it decreases all the way down to here. And then it increases. And then it decreases. So, you need to let me, so there's that part. Okay, now I'm going to do this part. Everything is just by looking at your calculator. So, my max and mins are done. My point of inflection are here. Basically, how do you find, I'm sorry, I made a mistake right here. This is a negative 2.25 and a positive 2, negative 0.25. So in order to find the point of inflection between these 2 points, all you do is take the midpoint between them, which would make sense that it's at 0. So I have a midpoint at 0, 0, or my point of inflection. And right here is where you go from concave up and it starts concave down, and right here. And how do you get those on your graphing calculator? You're just going to hit your trace button, and you're just going to hit the button until you think your calculator stops. And this is what I got, and yours could be a little different, but my other point of inflection is at 6.061 and a negative 0.149. That's where I dropped my, that's when I stopped my calculator. Again, everybody could have a different answer. I'm just showing you. Then you're going to trace it all the way to here, and you're going to stop where you think on your calculator it starts going from concave up to concave down. And my calculator told me a negative 5.697, comma 0.156. So that's approximately where everything is. So when I use now when I do the A part, I can precisely tell you where it's increasing at. It's going to increase from a negative 5.697 to a negative 2, union with. You see the red arrows increasing, and then there's the next increasing part is right here at 2 to 6.061. That's my increasing part. My decreasing part then needs to be the other part. So a negative infinity to a negative 5.697, union with, And you can see my arrows. It's going down, and I'll tell you where that's going down. Right here, 1. It's going down here, and it's going down here. So I just have to fill it in. A negative infinity to there, and then union with a negative 2 all the way down to a positive 2, union with 6.0612 infinity. Okay, now draw concave up and concave down. See? It's concave up to the point of inflection. So it's concave up to where it starts, the first one. So it's concave up from a negative infinity to a negative 5.697. It's also concave up from 0 to 6.061. So my D part needs to be the other part. A negative 5.697 to 0, union with 6.061 to infinity. And then E, my point of inflections, I listed them in blue. I really don't want to relist them, but my point of inflections are all in blue up there on my chart. Okay, the next problem is basically the same thing. I'm just going to show you the graph. I might not finish this one, but I'm going to give you a good idea. I gave you the window, and I told you what the graph looks like, and I'll show you kind of, this is just approximately kind of what the graph looks like. Okay, so at approximately right here, I'm going to put it in blue. You notice that it's concave up to here, and then it starts concave down to there. So this little blue area is called the point of inflection. And how did I find that? Use your trace and just start tracing till you think approximately on your calculator what point of inflection is. You can have totally different answers than the person next to you as long as it's approximately about where I'm at, 0.15. And 2.415 is what I got. So that's called my point of inflection. Do you notice that my graph is constantly increasing? So for my A, it's always increasing. For my B, it's never decreasing. For my C, I can't have a max or a min. None. You can't have a max or a min if it never goes from increasing to decreasing. I do have concavity though. I have concave up from a negative infinity to 5.15. And I have concave down from 5.15 to infinity. And I already told you what my point of inflection is, so I'm done with that problem. Okay, the next problem. Use the derivative and the graph of the derivative of f of x to find this. So, you can either use your graphing calculator to graph this, or you can go back to algebra 2 and graph this. So, I'm going to put an answer at -1. I know it crosses the x-axis at a -1, and I also know that it crosses the x-axis at a +2. We learned this from algebra 2 and college algebra where it crosses the x-axis at. Okay, now what I'm going to do is, if I put this all back together again, isn't this x to the third power? You should know what x to the third power is. It starts down and it ends up. Again, you could use your graphing calculator and figure out what this looks like. Since there's only one -1, it goes through the dot, but since there's two of them, it bounces off of the dot. Remember the bouncing and the non-bouncing. So there is my graph of my derivative. This is my graph of my derivative. So right away, when you get a derivative graph, you should go positive, or I'm not, sorry, you should go negative, 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 positive, 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 positive. Okay, so for A, they want me to find the local min and the local max. So, do you notice that my graph only goes from negative to positive? Do you notice that? It never goes from positive to negative. So there is no max. There is no max, but there is a min. And I can't tell you the exact spot, but I can tell you that there is a min at the x marker at x equals a negative 1. There is a min at x equals a negative 1. So far, so good. So that's what my derivative graph states. How do I find my point of inflection? Point of inflection measures the double derivative. So how do you find the double derivative? I'm going to go back to this and just bring this up one more time. Remember how we found the point of inflection? If we find the double derivative, and when we found the double derivative at x equals 1, didn't we set this equal to 0? So it needs to have a slope of 0. So I'm just going to go back to this problem. And if this is my first derivative, can I figure out where my first derivative equals 0 at, or horizontal? Isn't this one spot where my double derivative or my second slope equals 0? So I can tell you, just by looking at the first derivative, where my second derivative equals 0 at. My point of inflections are at x equals 0 and at 2, because that's where my first derivative slopes are 0. So that's all you have to do for this problem. Okay, we're done with that problem. The next problem, find the function with the given derivative whose graph passes through the point. Okay, so we need to find f of x. We need to go backwards, the antiderivative. So we add 1 to this, which makes 4/3, and we divide by 4/5. We add 1 to this, which makes 3, and we divide by 3. We add 1 to x to the first to make x to the second divided by 2, plus 1 is the same thing as x, and then you put a c at the end. So when you find the f of x, you just add 1 and divide by the number. Now all they want you to do is plug these numbers in. Well, 0 stands for y, and this stands for x. So in place of f of x, I put 0. In place of all the x's, I put 1. So 1 raised to the 4/3 divided by 4/5. Plus 1 to the third is 1/3. 1 to the second is 1/2. Plus 1 plus 6. So you're going to get 0 equals 1 to the 4/3. If you plug that into your calculator is 1. 1 divided by 4/3 is 0.75. Plus 1/3 is 0.3 repeating. 1/2 is 0.5 plus 1 plus 0 equals. If you add all 4 of these up, I think you get 2.583 plus c. So c must equal a negative 2.583. So all you have to do is go up into here, erase the c, and in place of the c, put a negative 2.583. And this is what I want to see as your final answer on the test. Okay, next one. You're planning to make an open rectangular box. So this is what it looks like. Well, for Pete's sake. And you're going to fold these up, and you're going to make your open box. Volume is equal to length times width times height. The height of the box is x. I put these in the wrong order. You're going to take 16 and subtract 2 x's from the length, because this whole thing is 16, and this whole thing is 10, so you have to subtract 2x from them. So you have volume equals x times 16 minus 2x times 10 minus 2x. You have to subtract 2x from the ends. Now, I'm going to multiply these together and then multiply by x. And you should get 4x to the third minus 52x to the second plus 160x. Once you get the volume, now you can find the derivative. 12x squared minus 104 x's plus 160. I would just use your poly simulator to come up with your two answers. X equals 6.6 repeating and 2. You use your poly simulator. One of these you can't keep. Usually you can't keep the bigger number. And I'll tell you why you can't keep this bigger number right here. So if I plug 6.6 back into the original, so think about plugging that number 6.6 back into the original. And for example, let's plug it right up into here. What happens if I put 6 in there? 2 times 6 is 12, correct? Or even bigger than that. What's 10 take away 12? Won't you have a negative volume? So you can't go with the bigger number. You're going to plug 2 into this so you can figure out the dimensions. 2 stands for the height. So how do you get the width and the length? I'm going to plug 2 in here. If I plug 2 in here, 2 times 2 is 4. 10 take away 4 is 6. 5. And if I plug 2 in here, I get 4. 16 take away 4 is 12. And we are talking inches. These are the dimensions of the box. It needs to be 2 by 6 by 12. And then they want you to go one step farther and figure out the volume. Well, multiply these three numbers together. What is 2 times 6 times 12? 144 inches cubed. And we are done with that problem. And I know I should have probably checked n's. I probably should have checked f of 0 and then f of 2. And then f of, with my highest value needs to be 5, my highest value. How did I get 5? I took this one and set it equal to 0, and that's how I got it. So, okay, next problem. Some of this got cut off, but I'll just give you a kind of a framework on how to do this. The first thing they want you to do is just plot points. So you're just going to look at the graph that they give you and plot points. So, 1, 2, 3, and 1, 2, 3. My x values are -3, -2, -1, 0, 1, 2, and 3, and I'm just going to ballpark it here. I'm going to go on -3 and up 58. Let's just pretend that's a -358. -248 is a little bit below it. -18 is really way below it. 0, -4 is about right here. 1, -12 is about right here. 2, 0 is about right there. And 330 is about right there. Okay, I just ballpark figured where my y values are. I just want an idea of what the graph looks like. So I'm just going to connect my points, and at least I know that this stands for f prime of x. Okay, so first part they want you to do is graph it. So I graphed it. This is the derivative, so we're going to do like we did on the last page. These are all positives. And these little guys are all negatives, right? So, for the b part, this is the a part, the graph. The b part, where is it increasing? Where is it decreasing? And where are their local extreme values? Well, it's increasing when your graphs are positive, and it's decreasing when it's negative. So it's increasing, and again, key word in this problem is the word estimate. Everyone could have a different answer, but you should put increasing from a -3 to this spot right there. Estimate. I'm just going to go to 0.5. Union with 2 to 3. I'm not going to infinity and a negative infinity because this is the only numbers that they have on the chart. Where is it decreasing? Just make sure you use these numbers as your markers. Where is their local extremes? I went from a positive to a negative and a negative to a positive, so I know that there's a max at x equals I made a mistake again, sorry. Negative 0.5, sorry. At a negative 0.5. There's a minimum at x equals 2. Okay, now comes the next part. They want a quadratic regression equation. We haven't done this in a long time, since chapter 1. They want a quadratic regression equation for this. So what you're going to do is you're going to go under stats. So hit your button stats, and under edit, under list 1 and list 2, you're going to put the x values, and you're going to put the y values down. So under stats, under edit, you're going to put list 1 and list 2, and you're going to list those on the chart, the negative 358, and you're going to put those down. And then you're going to hit calculate, and you want to calculate what? They're specifically telling you what kind it is. It's a quadratic regression. It'll say quadratic regression, and it'll give it to you. It'll spell it all out for you. It'll give it to you exactly what it is. It'll give you f prime of x equals 5.571 x to the second minus 6.714x minus 4.857. Then, the last part, they want you to find f of x. And how do you find f of x? You add 1 to this, and then you divide by 3. You add 1 to this, and you divide by 2. And you add 1 to this, and then just put a plus here. I'm happy if you leave it like that. If you want to tell me what those numbers are right here, you can tell me what that number is, but I'm happy that you're at that spot right there. Okay, next problems. These are really quick 10 and 11. You just have to know the process on how to do this. F is a local min. All you do is it tells you exactly what to do. Find the derivative, set it equal to 0. What's the derivative of this? Just follow exactly what it says to do. Find the derivative, which is 6x squared minus 2ax. And all you're going to do is set that equal to 0. And after you set that equal to 0, they're telling you what x equals. So can't you get a alone in the problem? If x is 2, that makes 24 minus 4a equals 0, because in place of all the x's I put 2. A negative 4a equals a negative 24, a equals 6. That's all you do. And same thing with this one. This is the first derivative. Here you find the second derivative. You do exactly the same thing. What's the second derivative of 6x squared? 12x. What's the second derivative of a negative 2ax? Negative 2a. Set that equal to 0. Again, now you got to change it. X is now 4. So you're going to put a 4 in place of the x, which makes 48 minus 2a equals 0. Negative 2a equals a negative 48. A equals 24. Done. Okay, number 11, I know it got cut off. You have the work for the problem. They're telling you exactly what to do in this problem. It says to take the derivative of one and set it equal to the derivative of the other. That's all you do is solve for x. What's the derivative of 20x? 20. What's the derivative of c to the x? 0.3x to the second minus 4.4x plus 6. So I just found the derivative of both of those two problems. That should only take but a second. And then, in order to come up with your two answers to this problem, you need to have 0 on this side. So it's 0.3x squared minus 0.4x minus 14. And now all I'm going to do is, again, use my Pauli simulator to solve this problem. I know there's two answers, and I'm just going to use my Pauli simulator to come with it. I'm going to get on my Pauli simulator x equals 7.5 and x equals a negative 6.2. But you can't have a negative revenue, so that's the final answer, is 7.5. Next problem. Number 12. Find the linearization equation for the following. Y minus y equals mx minus x. Step 1, you need to know how to find the slope. Step number 2, you need to know how to find point. To find the slope, another name for slope is derivative. So isn't the derivative of tangent secant squared x? And then you're going to put in, I'm going to draw a little picture of a negative pi over 4. Isn't that negative 45 degrees? 1 negative 1 square root of 2. Secant is cosine 1 over the square root of 2, which is really the square root of 2. So if you take the square root of 2 and square it, you get 2 for the answer. The point is a negative pi over 4. And then when you put a negative pi over 4 in here, you need to find the tangent of a negative pi over 4. Tangent is a negative 1 if you look up there. So then all you do is you plug this into the formula. Y, here's the y value right here. Y plus 1 equals, here's the slope, 2x plus pi over 4. You know what? If you want to leave it like that, you can leave it like that. I'm happy that you got it today. Okay, same thing with this problem. You find the slope and you find the point. How do you find the slope? You find the derivative of the original. The slope is 4x plus 4. After you find the derivative, which is 4x, 4, you plug 9 in, and you're going to get 40 for the slope. You're going to plug 9 into the original to find the y value, and I did that, and you get 195. Now that you know the slope, now that you know the point, you can plug it in. Y minus 195 equals 40, x minus 9. Leave it like that. You do not have to keep going if you don't want to. Okay, the next one, find dy dx first. Ln is an easy derivative. You put the original on the bottom, and you put the derivative on the top. The derivative of 4x minus 1 is 4. So that's the first part. Well, not really, because they want you to get dy alone. Okay, now, this is the A answer. The B is substitute in place of the x3, in place of dx is 0.04. I think you can finish this one on your own to come up with the answer that they have. Okay, last 3 problems. Hopefully it'll take about 45 minutes to watch this video. So, this is the base of a pyramid-shaped tape. So I'm going to try to draw a pyramid. I'm not going to be good at this. Anyway, the base of a pyramid-shaped tank is a square with sides length of 8 feet, and the vertex of the pyramid is 12 feet above. So this is 12, and these all have lengths of 8. And they give you the formula, volume equals 1/3 x squared h. So, just like the ones on your packet, you have to work in only one variable. So I'm going to do a proportion. I'm going to go x is to h as x is to h. I can't do r is to h as r is to h because it's not radius in this problem. There is no circles in this problem. So you're going to put in what you know. You're going to go 8 is to 12 as x is to h. And you're going to get x equals, all my solid, 12x equals 8h. So x equals 2/3 of an h. What you're going to do is, you're going to replace the x squared with this. Do not find the derivative yet. All we are doing is substituting letters for variables in. Do not find the derivative yet. Leave it as v equals 1/3, parentheses, in place of the x, we're going to put 2/3 h and square it. And then put another h next to it because there's another h in your problem. Again, I still haven't found my derivative. V equals 2/3 times, okay, so I've got 1/3. And then I got 2/3, which makes 4/9, which gives me 4 over 27 h to the third. So as you can see, I went from volume in 2 variables to volume in 1 variable. That's all I did. Have I found the derivative yet? No, I have not found the derivative yet. Now I'm going to find the derivative. B prime equals, put my 3 out in front, leave my 4/27, h to the second dh dt. They're going to give me information, and it tells me that my volume is changing at 4 cubic feet per minute. This ends up being 4/9 h squared dt. Okay, now comes this part. I forgot my dh. I'm trying to find the change in height, the change of the depth. So I'm trying to find this. I need to substitute something in here. So let's look back at it. They're telling me at that time it's 6 feet deep. At that time it's 6 feet deep. Okay, but I'm not going to put 6 in there because if you look at it, if I cut this off right now, you notice that it's a truncated picture. So basically, if it's a truncated picture, I'm not going to use the 6, but I'm going to take the height of the thing, which is 12, and subtract it from where the water is right now, and I'm going to use 6. It just so happens that these are identical. So you wouldn't have gotten this problem wrong if you forgot to subtract, because sometimes you subtract, sometimes you don't, but this is a truncated picture. So you're going to put 4 equals 4/9. 6 squared is 36 dh dt. 9 goes into 36 4 times, so 4 divided by 16 is going to give me dh dt. Most of you know that 4/16 is the same thing as 1/4, and 1/4 is the same thing as 0.25 dh dt, and we're talking feet per second. Okay, one more problem just like that one. We're just going to do another one to make sure you know what you're doing, except its volume equals 1/3 pi r squared h. So, again, the base of a cone-shaped tank, so now it looks like this again. And the height is 10, and the radius is 4, and it's filling up to 6. So again, you cannot find the derivative until you change it. So r is to h as r is to h. 4 is to 10 as r is to h. 4h is to 10r. So r is equal to 2/5 of an h. Again, leave it as b, 1/3 pi. In place of this r squared, you're going to substitute 2/5 h in there squared times h. V equals 1/3 pi over 4/25 h to the third power. Still have not found my derivative yet. V equals 4 over 75 pi h cubed. So this gigantic process right here was to go 2 variables down to 1 variable. Now that I have 1 variable, I can find my derivative. Put my 3 out in front, which makes 4 over 25 pi h to the second dh dt. Again, they tell you what your volume is changing at. Your volume is changing at 2 cubic feet per minute. Leave 425, leave pi. Still trying to find dh dt. Again, if it's an inverted cone, remember this is what a cone looks like. What happens if you cut this off? What happens if you cut this off right here? Does it still look like a cone to you if you cut it off? If you ate an ice cream cone, it would look the same. So, you don't have to subtract if it looks like this, but in this case, it looks like this. What happens if you cut it off? If you started eating it this way, an ice cream cone, it doesn't look like a cone. Since it's inverted, you need to take the height of the original, which is what? The height of the original is 10, and subtract it from the new height, which is 6. You're not going to use 6, you're going to use 4 in this problem. So you're going to put 16 here. Again, you only do this if it doesn't look like a cone. If it doesn't look like an ice cream cone. And then when you solve for it, you should get dHdt. Again, I don't know why it ends up being, again, 0.25 per minute. So it happens to be the same exact answer. Okay, last problem on this worksheet. A triangle problem. You should be pretty good at a triangle problem. Write down what you know. You want to use X's and Y's and Z's. You can use A, B's, and C's. I don't care what you use, just as long as you write letters down. So let's see what we know. 2 cars are approaching. One car is 80 feet. We know that. And the other car, and it's traveling at a rate of 20 feet per second. So we know dxdt is 20. Another car is 120 feet away, and it's traveling at a rate of 35 feet per second. And now comes the next part. Find the rate of change of the distance between the 2 cars. We're trying to find dv/dt. Do you notice that this is changing? You notice that this is changing? And do you notice that this is changing? Since all 3 are changing, you have to find the derivative of the formula x squared plus y squared equals z squared. You cannot put numbers in because all 3 of them are changing. So you need to find the derivative of x squared, which is 2x dx dt. The derivative of y squared, which is 2y dy dt. And the derivative of z squared, which is 2z dz dt. So, in place of x, I'm going to put 80. In place of dx dt, I'm going to put 20. In place of y, I'm going to put 120. In place of dy dt, I'm going to put 35. And then I have a 2, and then I still have these guys to fill in, correct? Well, we have 2 missing unknowns in this problem. And if you read it, we're supposed to find the rate of something changing. So this is the one that we need to find. How can we find z if we already know the x and the y? Can't we use the Pythagorean theorem to find the z? And to hurry this up, to finish this ends up being 144.2. I just stuck that in there. So I could easily find dv/dt. Figure out what this is, divide both sides by that 2 times the 144.2, and my final answer of this wonderful packet. Great, I didn't finish it. Let me look on my answer key. What do we have? 40.2 feet per second. Okay, so that's the whole review sheet. It lasted about close to 50 minutes. You can stop it, you can slow it down, you can repeat it. I know I went kind of fast, but I wanted to get this done before I left. So again, you can go over this whole review sheet over and over again if you don't understand something. And I explained it kind of fast, I know that, but you can always stop it and reverse it to hear it again. So, okay, be safe. Have a good day.